We have all been there. You are sitting at a desk, staring at a test, and resorting to guessing. When the grades finally come back, you are left wondering exactly how much those wrong answers drag down your final score. Intimidating word problems translate descriptions into specific mathematical instructions. When we map out the logic within the story, we can find the equations that determine the outcome. Consider this scenario. A student answers 120 questions. They earn 1 full mark for every correct answer, but lose a quarter mark for every wrong one. Their final result is a 90. This chart shows how paired linear equations function. By plotting the constraints of this test as two intersecting lines, we find a single point where both rules are satisfied simultaneously, pinpointing the exact number of guesses made. The first step in this process is identifying exactly what unknown values the problem is asking us to find. We assign variables to these unknowns. Let X be correct answers, and Y be wrong guesses. For our baseline equation, we use the total quantity. The student answered 120 questions, so the sum of correct and incorrect answers equals 120. This baseline equation represents the physical reality of the test completion. It counts the questions, but it hasn't yet accounted for the points. We need a second equation to track the weight or scoring value of those answers. We apply the positive weight first. Since every correct answer earns 1 mark, the value of our X variable is simply 1x. Pay close attention to the phrasing. Because marks are deducted, we use a subtraction sign, giving a penalty of -1/4 y. Setting this penalized value equal to the final score of 90 completes our second equation. With 2 variables and 2 governing rules, we now have a balanced system ready for resolution. To find our answer, we use the elimination method. It is the most efficient way to isolate variables when coefficients match perfectly. We subtract the entire bottom equation from the top. The x terms cancel out. Subtracting -1/4 y from y gives us 1.25 y. On the right side, 120 minus 90 leaves us with 30. Dividing 30 by 1.25 reveals that y equals 24, meaning 24 incorrect guesses. Substituting 24 back into our first equation, x plus 24 equals 120. Subtracting 24 from both sides shows that x equals 96. Algebra has reverse-engineered the student's exact testing strategy using nothing but the total question count and the final score. Our final result is definitive. The student answered 96 correctly and guessed incorrectly on 24. We can verify this against the scoring rules. The 24 wrong answers resulted in a 6-mark penalty. Subtracting those 6 marks from the 96 correct ones leaves us with the exact score of 90. This framework applies to any scenario with 2 constraints, whether you are calculating interest on investments or determining the layout of an urban kitchen. Apply this translation process to a different scenario. Look at these taxi fares and see if you can define the variables and establish the 2 governing equations yourself.